Hey guys, my name is xOctoManx and today we are talking about passes or basically waypoints. That means if you have characters which need to patrol around the scene on a given path, then we will create a pass system for them today. You can also use the passes for any shoot 'em up, like the enemy spawning somewhere on the right, and then we'll follow any path, maybe like a sinus curve or any other path you are going to give them, and then destroy each other, or basically destroy itself when it's leaving the screen by just using a boundary. So how can we basically do that? Well, at first we need some editor script to make it possible to actually create that point system or waypoint system visible in the screen. I won't go over and use berserkers for this because I don't have the knowledge for that, but I will try to make it as precise as possible for that particular pass system or waypoint system. So let's get started with that. And first I'm going to create a 3D object. By the way, I'm using Unity 5.3. Even if you don't have that one, it will still work in all the versions. So this cube is going to be my start point. You can also create an empty game object like this, but make sure that you give this any icon like this one maybe. The idea is to grab this one easily and drag the whole path around later on when you need to. So create a game object or an empty game object and give it any icon so you can select this easier and you don't need to go through the whole list and search what it is. So what this is going to be, this is going to be my path holder object. So any children of that path holder will make my path or basically the waypoint system. So let's get started encoding. I created a folder in my scripts folder called passes, and I created a C# script for this one, and this is going to be my editor path script. So today we will go and look into editor passes or basically editor creating editor scripts basically. So everything we change will automatically change in the list or basically in the scene. Where is it? I need to reload the solution maybe. Go into passes, there's my script. And what we want to do is we want to create, or basically at first we start with creating new namespace, and this namespace is going to use system.collection.generic because we are going to use a list for that. That list is actually holding informations of the pass itself, of course, or basically of all children of the passes. So what we can do is, at first we are going to create a new color, and this color is going to be our array color. I call this one array color, you can call this whatever you want, and this color will be set to be white at the beginning. This is going to be the color of our path in the editor, so we can see this actively doing anything. Since it is public, we can later on change this to red, green, yellow, whatever we want. Then we are creating our list. So this is going to be a public list in this case. Later on you will might want to make sure that it is not public anymore, since we don't write anything actively inside. And this is going to be a list of transforms or of type transforms, and I just call this list Pathobjs. So every path objects will be stored in that list. So and then we create a new list of transform, and we just end this line like so. And what we also need is a small array, which is a transform array or an array of type transform. So we use that square brackets and we just say the array. Okay, so we have a list, we have a transform, and we have a color we are using to create our editor script. In start, when we start when we start that script. Oh no, wait, we don't need start and update. What we do is we want to draw something inside of the editor, or want to make this one visible. So what we're gonna use is a function called onDrawGizmos. Like so. I'm gonna zoom in a bit to make it visible better. So we have a new function which is already part of mono behavior. onDrawGizmos is giving us the option to draw anything in the editor. Or basically not anything, but several types of gizmos we can draw in the editor. Also some kind of lines and rays and stuff. So what we want to set is, at first we want to set the gizmos color to be the color we just set. So we say gizmo.color equals ray color. Ray color, there we go. Then the next thing is we want to create stuff for the array, and the array basically holds or is looking through all children of our main object. So what we say is we want to get components in children, this one, of type transform, and we store all of them in the array. Then what we want to set is the pathobjs, which is the list of transforms. We want to clear this at start, or in every step. Basically, we are working in the inspector or in the editor. So now we go and loop through all of them, or through all the path objects we are just hopefully having in the array. So what we say is for each. Now we are looking for all types of transform. Again, for all transforms, we are just creating basically and we call this one pathobj, not objs, just obj. So for any particular path object we are having in the array. So we create basically new transform types called pathobj, and we use all of them which are currently in the array which we just got as a transform component from any children in our path holder. So hope you understand this. The next part is we just we do everything the same for every. That's basically what for each says. For every transform or every path object which has a transform on it, we want to do stuff like this. That means if the path obj we're just creating has not the same transform as the game object we are just on, that means if this if this is not equal this dot transform. So we want to make sure that we don't use the parent object. We just want the children object, and we don't want to make this two times or too often. Then we want to say we add that path obj to the path obj's list. Dot add, and then in brackets path obj, and we are doing this the whole time. So if we are updating that, like maybe we delete some game object from the scene or out of the path we are not using, then it will automatically update. That's why we clear the list at every step basically, and then we create or add new or delete new. So we update this the whole time. Then we're going using a for loop, and we now count through all the path objects in our list. So we start with an integer of called I. It's going to be 0 at the start, of course. Then what we want to do is if the path, if I is going to be smaller, if I is smaller than the path objs dot, and since we are using a list, we cannot use the length, we need to use count in this case. So if the count in that list is going to be bigger than I, then we just increment I, of course, like in every for loop. Oh. And what we want to do is at first we create a new vector3 for this, because we need the position of the latest game object in that list. Position is going to be equal to the pathobjs, and then we take the I we are just on in that for loop, and we take this I's position and store this in the position of that vector3. So basically this is going to be the last position, or the previous position, or basically the current position, and we in a second we will just go through that. Then we say if I is going to be bigger than 0, that means we have actually something in our array over from here, and that array, if this array is going to be bigger than or basically not the array, the list. If the list is going to be bigger than, bigger than 0, so we have anything inside, then we start to draw all that stuff. What we say is we create another vector3 of, and we call this one previous maybe. And this is going to be the pathobjs. And again, we take I as our counter, but we say -1, so we get the previous, not the current one. We get the one before of that, because we need a start point to draw our line from. And then we say dot position again, and in the next line we say, now the gizmo part comes here, so we say gizmos dot draw line, so we draw a line in the editor from the previous position to the current position. And to make things visible a bit easier, I'm going to also draw Gizmo a draw wired sphere. You can also use a cube, mesh, or whatever you want. I draw a wire sphere in the editor to see the start and end points of my game object, or basically my empty game objects. You can also use spheres instead of wire spheres and all the other things, but wire spheres are pretty much okay for this. I want to draw that sphere on the current position, so not on the previous one, just on the current one. And we can also say a radius for this one. In my case, I choose 0.3f. Oh, and the line like this. So go and save this editor path script and drag this onto our path holder. Give it a second to compile this. There we go. So what we start with, we have here our array color. We have a list of pathobjs. The array is basically not visible. It's invisible, as you can see, because it would just be troublesome to have both. Okay, so in our path holder, we right click and create an empty game object. You can call this whatever you want. I can call this, just path element or path object. This name does not matter in any way. So this pathobj should be at 0, 0, 0 on the path holder game object. And now we go and start to duplicate this just in the same game object. Now you can see what happened is it draws a wire sphere, and now we can actually drag around that wire sphere wherever we want. And that means it's drawing the line from the previous point, which is the first path object in the list, and the second one is automatically giving us any line. So the cool thing is right now we can also make this visible by selecting the Gizmos tab in the game field, or in the camera frustum basically, and now we can drag around the whole thing just by taking the path holder and dragging it wherever we want to start with. So the cool thing is I can go over and duplicate this the whole time. As you can see, I can create just a round path. and we can continue this however we want. Currently I'm in 2D mode, so I just create that curve in here. And now I want a game object to follow this one. There are several options again in here. I'm going to try to figure them, or basically show you everything I have or I can do for this. I basically may use another cube for this, or maybe another game object, maybe a capsule. This capsule will may change the direction of itself. So if you're using any game, or basically if whatever you're using later on to go on the path, make sure you don't take the 3D object itself. So always make sure that you're creating an empty game object and make this as children, the capsule or the 3D model you're using, directly on the empty game object, and change everything on that game object. I'm going to show you why in a second, or maybe two. Okay, so with that script done, we don't actually need to do anything else in the editor path script, I believe. Yep. So we can create our path, and we can also, as you can see right now, I can just easily duplicate this complete path and drag it wherever I want. I can create 3 paths of this. We cannot, I don't know if this is possible. We should be able to, as you can see, we can also rotate that path by 180 degrees and have a complete different path actually. So gonna delete this one. The cool thing is, as you can see, I can instantly grab this one and change everything I want to any need I have, and then do complete different stuff with that. Also, since I use that icons, I can easily grab them. So I don't need to go through my whole length of hierarchy objects and search all that stuff. That's not needed, as you can see. Pretty cool and pretty simple, I hope and believe. Okay, so this capsule is going to be our game object, which will have to wander around that. So what I do next is I create another new C# script, which is move on editor path. Move on. Oh, let's just call this one move on path script. Okay, this will be actually currently I will show you the difference. I will place this one directly on the capsule, and later on I will go over and take a game object to show you what the difference is. I hopefully can show you this as good as possible. So so let's go over and move that thing on the list. We at first need a lot of different variables for this. At first we need a connection to our editor path script. So this is going to be this, and we call this, or I call this one, the path to follow. So you always know, okay, the path to follow is the path I need to get basically for the capsule. The capsule needs to know which path to follow, or basically which path has an editor script on it, or editor path script on it. So the next thing is we need to do this public, which is an integer, and this is going to be our current waypoint ID. We are still using points. This is not actually a path, as you may have noticed. We have just points. So what I say or want to say is our current waypoint ID is going to be the integer of the array element in the list. And we start, of course, at 0. So another thing we want to consider is a public float speed. So the speed to wander around, or basically the speed to follow the path. The next one is going to be a private one, which is a float. You can also use or take this and make this public, but you don't want to fiddle around with that later on, and I don't want to change anything. It's going to be we start at 1.5 XOF. The reach distance, which we just created, is going to be if the capsule is like here with that pivot point, and the reach distance is the distance between the pivot point of the capsule and the point of the curve. So the smaller that is, the uglier is the movement. If you set reach distance to 0, it will follow that, that hard edges basically. So, but it will be precise on that with a reach distance of 1. If we have a small distance to them, if you have loopings or whatever, this won't look like, I don't know how this is called, but it will be a bit smoother, a smoother movement on that curves. So we don't use Bezier curves, as I said before. We just use that curves like, or basically that pass points as they are. Okay, the next thing is we want to take is a rotation speed, so we can rotate directly on the path. So public it's going to be of type float. And we can set this one to, I don't know, 0.5f for now. So the speed we are rotating around on the curve when we are looking to the next point, this is the rotation speed. What else would we need is another public. For now, later on, no, it needs to be public since we need to send in some informations. This is going to be the name of the path. So we say path name. Whoops. This path name gets passed into the move on path script when we are basically when we are instantiating our thingies, our game objects like the capsule, for example. Then we need to pass in the name and choose by the name we are choosing the path to follow. We're doing that directly on start. So at first, but we need more variables for the vector3's last position. So last position. So we need to check where we have been and where we want to go, and so we have a current position. You can also write this one shorter, like car pause, last pause, whatever. So this will stay private. So basically we don't need to write private in front. It's just basically, whatever you do, however you do. You can write in private in there or not. Those two will not be seen in the editor or in the inspector. Okay, at start we want to set our last position. That's the very first step. Our last position is going to be our transform position at start. Transform.position. So we have actually any position for now. We can go from and to. Also, I'm gonna write this one out and disable it for this for a second then. So what we want to set is the path to follow is going to be game object. Not this game object. We need the big game object. Dot find. So we want to find a game object in the list with the path name we are just passing in by this one. We pass this one in later on from, as I said, from the capsule when we are just getting the informations. And in that path name game object, we want to get the component of the editor script. So get component, editor path script. There we go. Then close the line like this. So yeah, this is going to be needed later on for when we are instantiating game objects. This is important. Okay, and an update. I'm gonna delete this stuff in here. We don't need that. An update, we are just doing all the transformations right now. So what we want to do is at first we want to check the distance, or basically create a distance between points. So we create a new float variable for this one called distance, and this is going to be the vector3, well, vector3.distance, no, not display. Well, that's funny. Oh, I forgot something. Like this one. So now it works, or should work. So vector3.distance, yeah, there we go. And now we want a distance from the editor path. So what we want to do is we want the path to follow, which is the editor path script, or which holds the editor's path script. And in that we have all the components we just added already, like the pathobjs, the ray color, and we already also have the connection to the pathobjs, yeah, like this. So path to follow pathobjs, and this one is an array, or basically a list of waypoint IDs, and what we want to set is the current waypoint ID. We want to get that waypoint ID. We are just in, and then we want to take the position of that one. Oh, wrong. And so this is the point we are starting at, and we want to have the distance to our current position. So it's going to be trans_position. Okay. So in the next line, I hope this is, let me just close the solutions. In the next line, we go and set our current transform.position. So we say transform.position is going to be equal to the vector3. So we basically, a vector3. And this time we are using move towards. That means we can move towards a point from a point. So the first parameter it's taking its current position, which is the from. The first point we're starting is basically our current position, so transform the position. And now we have a target position, as you can see in here. And this target is basically the path to follow, obj's current waypoint dot position. Gonna copy the whole part in here and paste this one in. And now we have the possibility to set some kind of speed. And this speed is going to be time.delta time, delta time, and times our speed variable we just created in the beginning. Close the line with that one, otherwise you will get an error. And basically, for now, it's just be it. So now we follow the path around. We get the distance from one point to another. Store this one in distance. What we will take. This is not what we are taking currently. We are just going through all of that and moving to the first point. So let's check our capsule move on path script. There we go. So currently we don't set the path to follow automatically, so we can basically go over and drag in the path to follow game object, which is a path holder, which already has all path objects in the element list. And we can now say, okay, there we go, here is the start of the waypoint 0, and it has no speed right now, so we can set the speed maybe to 2. What we will see next is the capsule, when we start playing, the capsule will go to the first waypoint in the list. Should. With a speed of 2. Now you can see it's going over to the first path point, and I will stop at that point, since we're not going through the whole list, and we don't increment that. So that's where reach distance and distance come in place. So what does it mean is, we creating a small if statement, in which we check the distance. So if the distance is going to be smaller or equal, the reach distance, that's funny, I should really take the reach distance, there we go. So if that is the case, then we need to increment our waypoint. So that means the current waypoint ID is going to be increased by 1. So just type plus plus or plus equal 1, it doesn't matter. Plus plus is a shorter way for this. Gonna save this, and what should be happen right now is, after it's compiling all that stuff, I'm gonna increase the speed to maybe 10 right now, since you have seen what it's doing. It will go to that point and then follow the whole path, and then it will get an index out of bounds, or basically, index out of range, because the list stopped, but it cannot increment the waypoint ID. What we can do at that point is basically we can hit or press a collide or place a collider there, and then say if this game object, whatever it is, we can just destroy it or place it somewhere, I don't know. But we can also do some kind of loop. That means if we are just at the maximum of the current waypoints, we just reset this one to 0, so we have a smooth transition between the first and the last waypoint, if we need that. That means we check this one with another waypoint, with another if statement. So we say if the current waypoint ID is going to be bigger or equal the path to follow dot path objs dot count. So if we are at the end of the list, then we like this. So when we are there, we just set the path, the current waypoint ID back to 0. So we restart that, and it will loop through the whole waypoints once again. So this is going to be equal to 0. Save. And let's go and check this one out. So what it should do, it should walk there, then move the whole path, and from this point, I'm going back to the first position, ignoring everything else. So as you can see, it walks there, and once it's there at that point, it starts to go back to the path holder object and move along the path once again. So that's pretty much everything for moving on a path. The only thing is you may want to have later on is if you have a fighting game or a shoot 'em up game or whatever, where you need to walk and look to the next point, because we have some cool ships and so on, and they can't just fly up and down, but they may want to rotate itself into the right direction. Then we can also do that by saying we create a new variable for this, just a var of rotation. You can always skip this part, you don't have to do that, but I want to show you how this is done. So the quaternion look rotation will be stored in this one, and the look rotation is basically calculated between, just copy this that part once again, the position we are going to minus the current position we are at, minus transform.position, no, not parent, transform.position. So this is going to be our look rotation. And now we just go over and transform that rotation onto our game object. So we say transform.rotation is going to be equal to quaternion.slurp. And in here we can again say from, to, and the speed. So from is again our transform.rotation. To is the rotation we just created in here. And the next thing is the speed. So we again, for the sake of being the same speed on any device you are doing that, we use time.delta time times our rotation speed. Rotation speed. There we go. So this is the speed we are rotating our or looking into the right direction. Okay. Now when we are starting this one, the capsule will look in any way, I don't know, maybe it's going on the z-axis. Now I can see it always looks with the z-axis to the front. Since you know this is going to be the z-axis, but you may want your capsule don't look that it is standing around, because the z-axis is going to the front, we can create a new game object, which is automatically or basically which we can work with a bit better. So what we can do is we create a game object, an empty one, under the capsule. Then I drag this one out, and now we can see we have a rotation of 90. What we want, or what I want, is I want the z-axis to look forward already. Let's see how we can do this. Okay, this is going to be backwards, and this is going to be forwards. What I do next is I place that capsule, which is currently looking in a very different direction. I take this -90 in here, drag the capsule on the game object, and now the game object will get our move editor on a move on path script. So I remove the component from the capsule and drag this one right here. Then I take any of path points I want to follow, drag this in here. I will show you in just a second that is you need this or don't need this one later on. And we set a walking speed or flying speed again, and that's for now it. Now the game object is going to take or is going to do the rotations instead of just the capsule. So now you can anytime manipulate the direction of your game objects and so on and so forth. Pretty cool. So I believe there's a small problem. I didn't. Yeah, that's okay. So now you can see the game object is starting or is basically following the z-axis, which is the blue one in here, I believe. Yeah, it should. And walk on that. Or is it the y-axis? I don't know. No, it's the z-axis. It's following the z-axis since it's a forward axis. Okay, so yeah, now we don't want to do that the whole time, and we may want to instantiate game objects and delete them after a while, or maybe when they hit something. So we can you can look my spawn game objects tutorial for this. If you want to spawn something on a particular point, you can just take the path holder game objects and then pass just everything in. What I want is that game object, just to show you how this is working later on. I want to create a small other script for the capsule, or basically for the game object, to pass in the path to follow automatically or randomly at start. So what I do is I create a new C# script, and I call this one just getPath. You don't need to do this because you will do that when you instantiating your game object. I don't want to do that right now, so I just want, for the sake of competition, I want to do this pretty quick in here. Gonna start monodevelop with getPath. Okay, so let's go through that pretty quick. Well, at first I want to loop through all existing paths, so I need to have an array of game objects. So public game object, and it's going to be array with the square brackets, and I call this one all paths. So here I just drag in all the paths I have, so the chip can basically change any randomly from that path list or from the path array. That's basically it for that. And what I do on start is, I don't need update for this. What I do at start is I just go through that list and take anything. So what I do is at first I create an integer of, I don't know, I call this just num, which is just a number, and the number is going to be random.range. So we create a random number between 0 and all passes dot length. So if the length of the game object array is going to be, I don't know, 5, then the number is going to be 5, or basically an outcome will be number 4. Okay, so what we do next is we set our current position, transform the position to be equal to the all nums, the all passes, of course, all passes, then the number we just calculated here, and of that transform, can't type today, transform.position. So we start at the pass point actually and set this onto that point where basically where the pass holder is. And then from there we are going forward by saying move on pass script. So we create a connection to the move on pass script. This is going to be your pass, just a name for this pass we're just storing. And what we want to do is we want to get, oh no, not get pass. We want to get the component called moveOnPass, which we just have on this game object. And then we want to set our pass, your pass.pass name. This is a pass name. Oops, with dot. The pass name is going to be the pass name we are just go and change in here from that string we just created. Here we need to make this one active, and we pass in the pass name of the all passes, the number we just calculated, and take the name of that, and that's it. So now we go, we create a random number from the length of the pass, between the 0 and the length of the pass of all the passes in the scene, or all passes you pass in that game object array. Then we set our position to that pass point. So we see a cool start, or basically it doesn't really matter where our game object is. So it's cool also for using object pooling later on. Then the movement script, or we create a connection to our moveOnPass script and store this one in your pass and get the component directly from the game object we are just on. I'm gonna drag this one over there when it's done compiling. Then we set the name of the pass, which we are just taken randomly basically, and set this to the pass we just calculated or randomly set in here. So what will happen right now is the pass to follow is going to be the game object's pass name we are just passing in at start, and get the component of the pass editor script, which is directly on the pass holder. So our game object right now has the getPass script, and also there's the array. What I can pass in right now is that two game objects. So I just drag them both here on, not this one, just directly on the pass all passes array. So now we have two elements, and that capsule can on start right now say I want to start here or there. I want to choose any of those two passes. So now it picked the first one, now it picked the second one, again the second one, and so on and so forth, and we'll go over the whole time. So now you should be able to know everything you need to know about passes, and this is the way you also pass in the pass name when you are instantiating the game object within your spawn object. Okay, that's everything I wanted to cover about passes, waypoints, and all the other things, the easy way, hopefully. So if you find this in any way helpful, just leave me a thumb up. If you have any questions about that or anything else, just leave me a comment under the video or a private message or whatever. And don't forget to subscribe to my channel if you haven't already, to see more videos in the future. So see you in the next part. Bye bye.